This is the water circles experiment. What you're going to need for this is a tray of water. As you can see, I'm using this glass baking tray, but you can use a metal baking tray, you can use a washing up bowl, you can use the sink with water in. I recommend though maybe using a tray because you want to have it standing so the water's nice and still, no waves all moving around. You're going to need some washing up liquid, and you can see here I've got a little egg cup with some washing up liquid in. And here you can see on this tissue I have some very thin cotton which I've made into a little loop, and you can see the little knot I tied there. So I've just made a little loop of cotton. Now obviously I want you to do the same thing. I want you then to pick up your little loop of cotton and I want you to rest it on the surface of the water. Okay, so gently lower it into the water and it should float on the surface. Try and make sure it stays open. Okay, now it's an irregular shape and that's fine. Now what I want you to do is get your digit, one finger here, and touch in the middle. See what happens. Not much. It's moving a bit, but not much. Now I want you to dip your finger into the washing up liquid and do the same thing with the washing up liquid on your finger. Off you go. So let's see what happens for me and see if it was the same for you. Dip my finger in, just a bit, you don't need much, just a tiny bit, in the middle. A perfect circle. So, how can it do that? Well, you'll notice first of all, look at what's happened now. It's moved across and it's now gone irregular shaped again. I'll explain why that happened in a minute. Let's think about what you first saw happen. We had an irregular shaped loop. You touched it with your finger, nothing happened. You got washing up liquid on your finger, you touched it in the middle and it very quickly pinged open into pretty much a perfect circle. Beautiful circle, wasn't it? Perfect circle. How come? Well, the reason is because on that surface of the water there's a layer. We call it a meniscus. And it's where the water meets the air. Now you can't see it here because of the way we're looking at this, but if you had it in a thin glass and some water in a glass and looked on the top layer, you'd see what looks a bit like a double layer. Now that's the meniscus. It has what we call surface tension properties. It pulls in all directions. You can imagine it to be a bit like a very thin rubbery sheet in the way it behaves. And it's pulling in all directions. Now when we laid our cotton on it initially, the cotton actually was, although it was sort of floating, it was actually resting in that meniscus as well. And it's still floating now, so it actually does float. But it was resting within the meniscus. But it was a bit irregular, wasn't it? Washing up liquid, when you put washing up liquid in water, the particles or molecules of washing up liquid get in with all the molecules of the water. Now the water molecules, they normally stick to each other. By the way, that's why water is wet. It's sticky. It sticks to itself and it sticks to other things. That's why it's wet. But water molecules stick to washing up liquid molecules more easily than they do to each other. And so it weakens them. So that layer we have here, which is pulling in all directions, where we touch it with the washing up liquid, suddenly becomes very weak and doesn't pull on itself so much. It just becomes very weak. So remember, let me move that back to the middle of it. Oh, look, it's pinged open again. So I've still got some washing up liquid on my fingers, so it's activated it again. But when I touched it initially, remember, all the water around the side is just pure water. When I touched it there, that washing up liquid was still a little bit on my finger still, suddenly weakened the meniscus there in the middle of the loop. Now the loop acted as a barrier, that little cotton acted as a little barrier. So the washing up liquid couldn't spread too far for the first few seconds. So it weakened the water inside of the loop. But all the water outside on the surface was still pulling pretty powerfully. So it got very weak in the middle and suddenly got pulled powerfully in all directions, and so the cotton loop was pulled in all directions with about the same amount of force, and that's why it pinged open into this lovely circle. But did you notice within a few seconds it actually started drifting? First it went over here, it still was a circle, but then it became an irregular circle. Now of course I've sunk it. It became an irregular circle, and that's because after a few seconds some of that washing up liquid actually managed to ooze out onto the outside of where the cotton was, and it weakened the meniscus around it. But first it pushed it through the water a bit, and then the water layer around wasn't pulling as much on the outside as it was before because of the effect of the washing up liquid spreading around. Although you can't see it, but the molecules will be spreading around, and so the forces all changed and it went back to an irregular shape again. And that's why it worked like that. So, are there any other things you could change to see what's going to happen? Well, I'm sure you can think of some things, but I'm going to give you just one or two to think about. What about trying loops of different sizes? Do you think that's going to make a difference? Of course, it will depend on the size of tray you're using, but let's assume you're using something about this size. You've seen the size of loop I used, it was about that big when it was open into a loop. What about if you made a loop which was much, much smaller, a tiny little loop, or maybe a great big one? I wonder what that would do. That'd be interesting. I wonder what would happen if you used cotton or even string that was thicker. Would it still work? Because we've used very thin cotton here. Would it still work if you used thicker or thinner stuff? What about if we change the temperature of the water? This water is room temperature, just about the same temperature as around us here now. What about if we use very hot water? Make sure it's not so hot you can't touch it, but hot water. See if it makes a difference. What about freezing cold water? Do you think that's going to work? Would it work in the same way? I wonder. And of course, what about different containers? What about if we change the container? Maybe use something much, much wider or much smaller or deeper, something like that. I'll leave that to you.